Okay, we'll directly go to proof. We have already done the compound. Main thing, all these identities are called compound identities. So this is actually lesson number 7.2, right? We finished 7.1. So 7.2 is more about all these identities that you see. We did this one. I put the link also. Some of you must have seen, some of you not seen. But right now, this is the beginning. The cosine A minus B, cosine A. Last class we did some problems on this. Okay, so still we'll be working more tomorrow. But main thing, let's see why is this cosine A plus B. So I'll begin here straight away the third one. So the third question is cosine of A plus B. So we'll begin with the left. So this is the left, and we want to see whether we can get the right. So this is the left, cosine A plus B. There's the red A and the blue B. Of course, you can see cosine, cosine minus sine, sine. So the question is why? Okay. So what is that one step you can think is, how do I change this to minus? Somebody help me? So I'm going to use now two pair. One I'll use this bracket. So I have a result right. And then A stays A. How can I write B as? Somebody quickly tell. Can I write it in terms of minus? Using this trick. So remember, if I have a minus plus 3, I can always write it negative of this, right? Can I change like that here?
Minus negative.
Yeah. Let me get the marker. Yeah, minus of? Yes. So we'll put a red color minus, put a solid red, okay? And then inside I'm gonna write this green color, the B will be now. Is that okay? That's all. So instead of B, it is in the formula, you see, this one, cosine A minus B. So this B is replaced by negative B, okay? So now let's use the fourth formula. So what do I write? This equals. Can somebody help me quickly? Just say it. While you write it here, would you like to help me? What should I write?
You could put cos.
Cos. Okay, let me use. We'll put in the formula A is red A, right? Let's put it like a A. That's the formula is a A, correct? But the blue one, let's use the real blue also here. So this, instead of green, I'm making it, is that okay? So it is the green color now. Is that okay? Makes sense? So where did it come and tell me quickly? So what should I write?
You could do cosine A
Okay.
minus.
So cosine of A, what is A means? The red one, right? Okay, then times
Negative, no.
the what?
Oh, okay.
Yeah, I'm going according to that formula then.
Times cosine
Cos
negative B.
negative B, I'm going to use. Is that okay? See, can you guys, please don't copy right now, don't copy, just focus this side, okay? Jocelyn, Bianca, okay? Don't worry about the chart. We are going one. Say it again. Oh, okay. So that's negative B. Then what do you have after that? In the formula?
Plus sine A times
Plus, very good, sine
times sine A.
A. So that's the red color, right? And then times,
Times sine negative B.
and the negative B is, yeah, that's the one, correct? Is that right? And then your question now, what do we do next is, if you have a cosine of negative B, I don't have that chart, do I have those formulas put? If you remember, let me write it right here just in case. Remember earlier sine of trigonometric of negative angles, it's like sine of negative theta is negative sine theta. We have done this, you may have forgotten, take note. Cosine is the only one, the minus doesn't matter, you get back the same thing, but the tan of minus theta is minus theta. And cosecant of minus theta is minus cosecant theta, but the secant minus theta gets back to secant theta, and cotangent of minus theta is minus cotangent. The main thing is focus right here is, there is a sine and cosine, so the first two. So these two. Thank you. So if you see this, missile, do you see cosine A? Can we do anything to do? Can we change it or it stays the same? Yeah, it stays the same. I wanted to hear that. So this stays the same. You can't do nothing. But there's a minus here, right? So what do I do with this minus sign? Look at the formula for cosine. You see that? Minus sign just vanishes. Correct? So if you forget, I just wanted to, if you remember that unit circle that we did, and if you have an angle like this theta, up theta, which is theta here, remember, this is cosine theta, and this is sine of theta. Do you remember that? Nobody? Yes or no? And I can do the same thing at the bottom with the same angle, but the clockwise direction, which is minus theta. So this one is cosine of minus theta and sine of minus theta, agreed? So this is, now if you see this part, cosine, for this, if you look at this part, the y coordinates, the x coordinate is always positive, this is positive, this is also positive, can you see that? So cosine of minus, by definition, this is xy, agree? That's the x by xy. X is cosine, y is sine. This is x and y, correct? So if I start with this cosine of minus, so here x is, this x coordinate is cosine of minus theta, correct? Yes or not? And what is x here? Cosine theta? I got lost, listen. Here x is cos theta, right? But here x is cosine minus theta. But x is the same here and here. This is minus y. You have to be very careful. This is minus y here. The y coordinate is minus y here. So here x is cosine theta, and here x is cosine minus theta. So that's why it doesn't matter. Can you see this? Cosine of minus theta is cosine. So minus just vanishes. So we can write this directly as cosine of just a b. Done. Okay. Then plus sine of this a times, what about this minus b now? What do you do with this minus sign here? Can you see this minus sign? Yeah, I put it in the beginning. That's a nice way. So this is same as minus sine of, correct? And then you have to get away with the negative. Just there's a positive and negative, so we can. It is like if I ask you what is plus 2 times negative 3, don't we say negative 6? Yes or no? Same thing here. So we can write this is equal to cosine of A times cosine of B, and this plus and minus change to what? Minus sine of A and sine of, done, correct? So do you see the right side? Is it really correct? Do you get the same thing? Nobody saying yes. Cosine A, cosine B, plus sine A, sine B, and you're done. So that takes care of the. Okay. This is right, and I'll just say right. We began with left. Now that we got the right. So what did we prove then? So the goal is, can every student know why it is like this way? Cosine A, cosine B, minus. So if there's a plus, you just change minus sine A and sine B. Is that okay? Now the question is, the second one, let's prove, go to do the first one. Let's start with what? Left. And the left is sine of A plus the blue B. Let's see why. I'll take a while. I'll wait for 30 seconds for everybody to get ready with that. Even though I gave you exercise 7.2, did I give you 7.2 homework? Not yet, right? Okay, so that, oh, you have, I think you guys missed. So anyway, that's where we are going to apply y and how to use this. So last class, Jaslyn and Bianca, I think you missed the class. There was a question like this, cosine of, I think 17 pi by 12 like this. So the question is, how do we find 17? Then and then we try to break the 17 into, should I use 1 and 16 or 2 and 15 or 3 and you can check out all those and see which one you pick, those which are multiple of 12. What did we pick? You remember for this 17? Check your notebook. Did I take 17 or something?
9 and 8.
9 and 8. Can you see? So even if you miss the class, you did not lose nothing. It's just that no matter what stupid thing is given here, just think of, let's say 17, right? So 1 plus 16 is 17. 2 plus 15 is 17. 3 and 14 also is 17. But why did we pick, what about that?
9 and 8.
What was the reason we picked 9 and 8? Because 9 and 12 we can always divide something, right? 8 and 12 also divides. That's why we picked that. And then the rest is history. So if you miss that, I don't know. Did I record that day? No. No, I did not do that. Okay, so let's check that. Okay, start. So now the problem is, watch this. We know only these two, correct? Cosine. We don't have sine formula. We don't know yet. But the question is why. So can we change this to cosine? Can I write, instead of sine, can I replace it by cosine? But if I replace to cosine, what is that thing? Some change works out. And for this, if you forget, I still want to get those formulas here. And where is that chart? Bianca, did you take it home? Okay. Anything strikes you? Can we change sine to cosine or cosine to sine? Look at which of these formulas will help you. I'm giving you a trick. Think of the co-function. One of them should help. And what is theta? Yeah, a plus b, there you go, you got it. So even the theta which is there in the formula, see this? How did you know that? It's there, what are you talking about? So do you see that? Cosine theta is same as sine pi by 2. Forget pi by 2, pi by 2 is too complex, let's put it 90 degrees, make it easy. 90 is easy to understand. Pi by 2 is like, still we get confused. So cosine, when you change to sine, just subtract that, whatever that thing. Now in this example, what I am subtracting is, okay, equals, now pi by 2, right? Can you see this pi by 2 here? But instead of pi by 2, I'm going to use 90 degrees. Okay? Minus the theta. The theta right now here is this whole thing. This whole thing is like a theta, right? Can you see that theta? This is the theta, write it like this, like an egg shape, oval shape, vertical egg. So that is the red A plus the B. Is that okay? You see? That's the only difficult step. The rest is easy. If you know how to write this, that's it. You just change to 90 minus. Now you have to think, use cosine formula. So use cosine rule. Now what is that cosine rule means? This is like cosine. So this formula also is written as this part. I'm gonna write it cosine. Instead of A plus B, I can write it cosine of first minus second. So if it is this way, we can write it as, answer is cosine first, cosine second. This is another way to remember, plus sine first times sine second. Do you know what I'm doing? Instead of the letters A and B, you can say 1 and 2, first and the second. Now why I'm using is, this is like first and second type. This is like your first angle, and what is this one is the? Do you see? This is first and this is correct. But before that, before that, it won't help us. Can we do some rearranging? Before even applying it, I want you to think of some can we rearrange this? Open the parenthesis, what do you get? So this is cosine, everything stays the same. The 90 degrees stays the same. I'm opening the parenthesis, okay? So minus the angle A, and then this minus multiplies to plus, changes to minus the blue. Do you guys agree? Okay? And now I want to call this as the first part, this as the second. And for that, let's write one more step to cosine of, and put a parenthesis for this as 90 minus A minus B. Okay, let's see. So little kind of a rearrangement is done here. So instead of, you first open the parenthesis and then you try to put this together, and your question will be now, why the heck we did this? And there's a reason, because 90 minus A, we know the formula right here. We can always make it easier. So this equals, so first call this as the first, so kind of red color I use. This is, this is the first, and the blue is the second. So now you're going back to the formula number 4. I'll put it here, apply formula number 4. And this time, Jaslyn, can you help me? Equals cos, tell, say, what's the first part here? You can think like 1 and 2, right? So you say cosine first, cosine second, plus sine first, sine second, agree? So now we are deciding which is first and which is second. So that this whole thing is like first, 90 minus C. Okay, Bianca? And that's the second. Can you say it down, Jasmine?
I don't understand.
Valerie, can you speak?
Would you do cosine 90 minus A
90 minus A, and then
times cosine negative B
cosine B, very good, then
plus sine 90 minus A?
sine this color, this is first part, that's what I'm saying, right? I think that's where, now that I don't want to put color, I think we should be by now knowing what we are doing is the first part here is this whole thing 90 minus A, right? That's the first part. And then times sine of,
Negative B.
no, not negative,
Just B.
just that part. This is the second part. This minus is like a formula minus. Is this minus sign? So this minus is the formula. So this A and B, the first is the red color, second is the blue color. Is that okay? So the first is the, this is like the first is the red color, the first one, see? And then the second is the blue color. This is the blue color, blue. Okay? So this whole thing is like a first, second, and this becomes B. Is that okay? And we are almost done. But what is cosine 90 minus EA? You can use the same. See this formula, cosine theta is sine 90 minus theta. You can use also for sine. So if here, even though we want to know what is it, but we know for sine, but it is also for cosine. If it is cosine 90 minus theta, this becomes, they change, sine. Is that okay? I think I better write that. So what I am trying to say is like this. On top of the page, write down sine 90 minus theta is cosine theta, and cosine 90 minus theta is sine theta. Always true. Can you take note of this, just in case you forget? Okay. So what I'm applying here is, now that you have this part, so this is going to apply right here. Can you see this? So cosine 90 minus A will give you back to what? Sine of A, correct? Sine A, this stays the same, but what about this part? This you apply right here, correct? So it is cosine of A and this is the right side. Got it? Done. Did you get something? 100%? Little lost, right? So your question is, how did we get, of course, remember we did this, we forget, and if this was theta, this is 90, this is 90 minus theta. I can call this as A, B, and C. You can always check this out, right? So those of you who forget, if this is the main angle theta, if I write sine theta, opposite of a hypotenuse, and you can see across is B, that's the opposite, this is the hypotenuse, right? Agree? But also, if I use the top angle, this angle from top, which is 90 minus theta, and I can use cosine there. So cosine 90 minus theta, the formula is adjacent of a hypotenuse, but for this becomes the adjacent, this is the adjacent B. This is the hypotenuse, right? So adjacent over, correct? So that also is B over C, correct? So so irritating. this sine of that angle is B over C, but if you use that angle, it is also B over C. Cosine. So sine of this angle is B over C. Cosine of this angle is adjacent over hypotenuse. So right now we are not checking, we don't want to know all this why and how, you just have to remember that's the formula. There you go. Nobody cares now, you should be knowing that before. Now, and this is the right side we are done. Let's do quickly problem this one, the third one. I'm gonna make it small here. Let's start with the left. We did the first one, right? So the left is sine A, huh? Of what? Ah, okay. Yeah, I took a lot of trouble to put the color, right? So the second one is sine A minus B. Yeah, that's right. So now we know this, right? So knowing this, so now in knowing this formula, can you prove this? Can you prove the second one? So now that you already know first, how do I prove the second? Can I wipe this off, Bianca? Check your photo, please, whether it's clear or not. Okay. Okay. So the first step is change minus to plus, because you know the formula for plus sign, right? So we will try to change minus to plus, and the only option is what? You can change this to A stays the same. Instead of minus, I'm gonna put plus, and this stays inside minus B. Is that okay? So this is a trick. So the red color and the, you can think of red color or the first and the second. You can always think that this is the first and this is the second, right? Can you finish it yourself? So this equals, what should I write? Sine of the first. The formula is right here, right? Sine A cos B cos A sine B. Remember that thing? So whenever the formula for sine is, you need to use both sine cos. But for the cosine formula, is always cos cos sine sine. So sine A, sine of the first, cosine of the second, plus, so the formula, I'm using formula number 1, plus cos, now you replace, now you swap this sine cos, now it is cosine minus sine. So all you do is put the first one, red color, and then the minus. Okay? But then you know what is cosine of minus b from that? Remember earlier I showed you, cosine is the one where minus sign vanishes. So it is back to cosine b, this cosine of a, but this minus sign gets multiplied outside. Remember there's a minus here, this minus is negative of sine b, which gets directly multiplied here, and you get the answer like this. Ha ha ha. And you're done, you got the right side, this is the right side. The goal of this time we spend is to know why the hell these formulas exist, and now you know how it is, right? And we applied it last time. I tried to do, I think we could do sine of 15 or cosine of 15 or sine of 75, cosine of 75. We also did sine of 105. So these are the only known important angles they can ask you question on, where Bianca and Jaslyn, this is what we did last time. And we wrote it like 45 minus 30. This we use 60 plus 45 because that's how it add up to 105. And this you can add 40 plus 45 plus 30. So the known ones, right? Do you remember whether you did that? Okay, now what we do next is let's do the next group of problem of a tangent. Okay, so I hope I'll just cut short this one, or this one I will open the new one. Okay.